Hello guys. Mic is on my head. Regan, yep. Dan. Yep. Frank. Yep. Anybody else out there? So I'm missing Will, Sam, S, Lottie, Carrie, Samuel, and Casper. If you guys are there, just drop me an email maybe if you can't or anything. Cool. Oh, Sam's there. Cool. All right. So today we're going to work our way through a pure past paper. This will probably take 2 lectures, but we'll see how we get on with it. So if you guys would like to start this one on the screen, it's 3 marks. I'm going to give you 3 minutes. Starting from now. Cool. Yeah, I wrote down the wrong one. So question 5. Here you go. This one's 5 marks. So let's make it 5 minutes. Cool. Sorry about that, guys. Here you go. All right, guys. So I'm just gonna tweak this. Cool. All right. Can you still all hear me? Yeah, good. Don't know why I'm so red today. I'm using a different computer because the other one was struggling. So should be a higher definition, but yeah, I'm a bit red. So there we go. All right. Let's zoom out for this one then. All right. So basically just trying to differentiate this. We need to use the quotient rule. So u is going to be 3 sine theta, and v is going to be 2 sine theta plus 2 cos theta. If we differentiate u dash, we're going to get 3 cos theta. If we differentiate v dash is going to be 2 cos theta minus 2 sine theta. So our equation for this is dy dx is v u dash minus u v dash over v squared. So we'll put that all together, put it all into the equation, and we're going to get dy dx is vu dash, so 3 cos theta, 2 sine theta plus 2 cos theta minus uv dash, so 3, I'm going to run out of room here by the looks of it, 3 sine theta, 2 cos theta minus 2 sine theta, all over v squared, 2 sine theta plus 2 cos theta all squared. Cool, lovely. So we're going to expand all of this stuff. So if I get rid of everything else, we'll do some simplifying. We're going to expand everything and then try and use some trig identities. Cool. So we'll get, let's expand the top first. So dy by dx is 6 sine theta cos theta plus 6 cos squared theta minus 6 sine theta cos theta plus 6 sine squared theta all over 4 sine squared theta plus 2 times 2 is 4 times 2 is 8 sine theta cos theta plus 4 cos squared theta. All right, now the numerator of this one, we can see there's a sine plus a cos squared, so those are going to become 1, and we've got 6 lots of that, so we're going to get 6 on top. And then we got sine theta cos theta minus sine theta cos theta, so they all cancel. So we did, in fact, just get 6 on top. And then on bottom, we got sine theta cos theta again. So they add together to give us 4. Plus 8 sine theta cos theta. Well, that's 4 lots of sine 2 theta. So we use a double angle formula there. So 4 lots of sine 2 theta. If we look at what we're trying to get to, a over 1 plus sine 2 theta, we need to divide the whole of our equation, top and bottom, by 4. So we get 3 over 2 over 1 plus sine 2 theta. So A is 3 over 2, as Kezia said in the comments. Well done, Kezia. Cool. Everyone okay with that? Anyone got any questions? No? All right, let's move it on. So next one is this, which is I think it's a coordinate geometry. Yeah, coordinate geometry question, bit of differentiation, tangents and whatnot. So this is a 10-mark question, so let's set the timer for 10 minutes. And timer starts now. No worries, Hannah. I'll take you off on the register now. All right. So yeah, make sure you're commenting, guys, if you need any help or if you. Oh right, yeah, we have some comments. Cool. Stan and Kezia done part B. Good. Right, let's have a look. Good. Right. So we've got the tangent, which is 2x plus 1. We want to try and find the equation of the line PA. So I know the gradient of the line PA must be the negative reciprocal of 2, so that's minus a half. And we know the point 0.75 is on this line, so I can use both those to find the equation of this mystery line. So y take 5 is minus a half, x take 7. And then we just need to rearrange this. So we're trying to get 2y, so I'm going to times everything by 2 to get 2y minus 10 is minus x. Oop, no room there. 2y minus 10 is minus x plus 7. Add 10 to each side. 2y is minus x plus 17, which is what we wanted. And move the x over to the other side as well. So that's part A. Part B, find an equation for the circle. Well, we know the center of the circle. All we need is the radius, and the radius is the length of the line PA. So if we work out where those two lines meet each other, so we're going to say 2x plus 1 is we're going to sub that into the other equation. So I've subbed this into the 2y there. Expand it, 4x plus 2 plus x, 17. 5x is 15, so therefore x is 3. We can put that back in to find y. So y is 2x plus 1, so y is going to be 7. And we can find the length of line between that point and our center. So 7, take 5 squared, plus 3, take 7 squared, gives us 2 squared, which is 4, minus 4 squared, which is 16, so that gives us root 20. So my radius is root 20, so my circle equation is going to be x take 5 squared plus y take 7 squared equals 20, which is what you guys put. Good. Okay, and the last bit is a discriminant kind of question, which says there's another tangent, 2x plus k, is also a tangent to the circle. Find the constant k. So basically it means the circle and the other tangent, they have to meet in one place because the tangent only meets in one place. So we're going to say if we solve them simultaneously, then the quadratic we get will only have one solution. So if I sub them both together, we're going to put 2x plus k in there as y, which will give me x minus 5 squared plus 2x plus k take 7 squared equals 20. So that, it doesn't really look like it at the moment, but that is a quadratic in x. The discriminant of that, b squared minus 4ac, should equal 0 because it's a tangent, it meets it in one place. So we're going to expand all this, turn it into a quadratic, and then run the discriminant on it. Dan, I think you are right though. That rings a bell from when I did this last week. So expanding this, x squared take 10x plus 25. This one's a bit more difficult to expand. I'm going to treat this bit as one term and the other bit as a different term. So we're going to get 2x plus k all squared. Then we're going to get minus 7 times 2x plus k. We're going to get two of those terms. So instead of 7, I'm going to write minus 14. Then on the end, we're going to get plus 49 equals 20. So that's just from expanding it. We'll go down to the next layer and expand the other brackets as well. So x squared, take 10x, plus 25, plus 4x squared, plus 4kx, plus k squared, minus 28x, minus 14k, plus 49 equals 20. Right, so we're going to simplify that, try and get it in a quadratic form. So x squared terms, we have 4x squared and x squared, so that gives me 5x squared. X terms, well, we have minus 10, minus 28, and 4kx, so that gives me, I feel like this might be wrong, but we'll see. If Dan, if you got different to this, let me know. Minus 38x plus 4kx, there's my x terms together. Oh, I did something silly there. I can't remember what I wrote now. Let's keep going. We'll see if this does work out. Although 38 plus 4 doesn't ring any bells. Yeah. Okay. And then at the end we're going to get the number terms. So we've got 25, 49, k squared minus 14k, and 20. So we're going to take 20 from each side, which gives me 5. Add that to 49, which gives me 54. So plus 54 plus k squared. Can't fit that in. Plus k squared minus 14k plus 54. Oh no, I got the x's and y's wrong. Okay, sorry guys. I was rushing through that a bit. Alright, let's fix it. So, yeah, x minus 7, oh, awful, plus y take 5 squared equals 20. Line there, 2x plus k. So I'll expand and put it all together. You know what the method is now. So y here is going to be 2x plus k. That's k, not 5. So we get to there. Expand everything another step. Okay, yeah, this feels better. So collecting all our terms, x squared terms, we still have 5 of them. X terms, well, we now got minus 20, minus 14, so that's minus 34x plus 4kx. And on the end, we're going to get plus 54 plus k squared take 10k equals 0. Okay. So we need to do b squared minus 4ac. So the a term is going to be 5. B, well, to get b, we need to factorize these two. So we've got 4k minus 34x's. And my c term is going to be all the stuff at the end. K squared minus 10k plus 54. So we're going to put all of that into the b squared minus 4ac equation. So b squared gives me 4k take 34 squared minus 4 lots of A times C, and that should equal 0. So once more we need to expand a load of stuff. So I'm going to use my calculator for this because there's some big numbers and I am likely to make a mistake. So we get 16k squared minus 272k plus 1156. And then we're going to take away 20 lots of everything in here. So take away 20k squared plus 200k. Take away 1080. Seems a lot quite nasty equation for 3 marks. It does. We'll see. Dan said he did it a different way, so yeah. See if Dan's got a different method. But this is how it's not a hard method. You just got a big equation, but it is just a quadratic and some brackets. So yeah. So we get minus 4k squared, minus 72k, and then what's that going to be plus 76. Cool, that does divide by 4, but let's just type that into the calculator and solve it. So minus 4, minus 72, and 76. Which gives me x equals minus 19, or, well, let's use k instead now. K equals minus 19, or k equals 1. It says there k is not 1, so it's not that, so therefore k is minus 19. Cool. Right, Dan, how did you do it? Because I'd be interested to know, see if you got a quicker, more efficient method. We'll see what Dan says, but let's skip over. The part C, he used line PA. Okay, let's have a look at this. Use PA from part 1 and the equation for the circle, and you solve them simultaneously. Oh, okay. I see. Cool. And then you use that to work out what K must be. Yeah, that's a nice way of doing it. Yeah, and then worked out from there. Yeah, that's nice. That's probably what they wanted you to do for 3 marks. I really like doing these discriminant circle questions. Right. Anyway, next one. So we've got integration here. It's 7 marks worth of integration. Yeah, and then your intercept comes out as minus 19. Yeah, that's a neat way of doing it. Where's my timer gone? So 7 minutes for this one. Yeah, less painful, less fun as well though. Maybe Yeah, that looks good, Hannah. Cool. So you can do part B as well. Cool. Yeah. So Kezia, Hannah, good job. I think you both, well, at least got the first bit right. Okay, so we need to do these integrals and worry about what it says independent inversely proportional afterwards. So first integral is 2 over 3x minus k, so that's going to turn into a ln 3x minus k. We just need to now check what needs to happen to this. So if we differentiated this, we get 3 out the front. We don't want 3 out the front, we want 2 out the front, so we need to times it by 2 and divide it by 3. So that's our answer. Put the limits in, which are k and 3k. So put 3k in first, and we're going to get 2/3 ln of 9k, take k, take away 2/3 ln 3k minus k, which is, we can use log rules to divide those two. So we get 2/3 ln 8k over 2k. K's cancel, 8 over 2 is 4, so we get 2/3 ln 4. Now, there's no k's in the answer, therefore that answer is independent of k. So no k's, therefore independent of k. So that's what it means for the first bit. The second one, we're trying to show it's inversely proportional. So we're going to do this integral. Can't use ln on this one because it's to the power 2. So anything to the power not 1, we need to use negative powers for this. So we get 2 lots of 2x, take k to the minus 2. If you integrate that, the power is going to go up. So we're going to get equals 2x minus k to the minus 1. And if we differentiate this to check, we'd get 2 out the front, which we do want. We'd also get a minus out the front, which we don't want. So we need to put a minus in to counteract the minus we don't want. Then we can put our limits in, 2k and k. So we're going to get minus 4k, take k to the minus 1, take away minus plus 2k, take k to the minus 1. Right, so if we sort that out, we're going to get minus 1 over 3k plus 1 over k, which in other words is 1 over k, take a third of 1 over k, which equals 2/3 of 1 over k. K is on the bottom, k in denominator, therefore inversely proportional. There you go, that's it. Right, we're doing pretty well for time today. Next one, I haven't actually loaded up on the page. What is the next one? Question. Come on. Question 8. Do you mind expanding? Okay, yeah, we'll do that now quickly, Sam. No problem. So 2x plus k, take 5 squared. So this, I know this is a quadratic because k is a number, but we got 3 terms. So the way to expand this, I just pretended that was one thing. So with a quadratic, you got a plus b, you get a squared plus 2ab plus b squared from the binomial expansion. So if I treat the whole first bit as my first term, we're going to get 2x plus k all squared, so that is just a squared, plus 2 lots of ab, well, it's going to be 2x plus k times 1 minus 5, then plus b squared, so plus 25. Then I went down a step, expanded the first bracket. I know that's quadratic as well, so we get 4x squared plus 2 times k, so that's going to be 4kx plus k squared. Next bracket, plus minus 5 times 2 is minus 10, so we get minus 20x, and then minus 10k plus 25. And then you just simplify it after that. So that's what I did. Treated that as two bits for a, which then squared like that. Hopefully that makes sense. Cool. Right, so next question, I think it's on Dropbox. I think it's this past paper. Let's have a look. I think we were on 8, 7, yeah, question 8. There you go, cool. So 5-mark question. It shouldn't be too bad, this one. Yeah, it's just a modeling question. So it's seeing how well you can understand what's going on in this model. So 5 minutes starting So find the depth. This is a bit. Oh no, I had the mic off for all that. First bit, alright guys, so you're just putting in T is 6.5 and finding the answer. For this one then, it takes 2 hours to load its cargo, so it isn't going to be leaving before 8:30. So we need to find the first time after 8:30 a.m. that the depth is at least 3.8. So we want D to be greater than 3.8. So basically trying to solve this, so we're going to say 3.8 equals 5 plus 2 sine 30. Take 5 from each side to get minus 1.2 is 2 sine 30. Divide by 2, minus 0.6 is sine 30t. Alright, so I'm going to do a sketch for this. We've got a sine graph. It has been stretched. I'm going to do a few bits on here. And we want to find when the time is minus 0.6. So these are the times we've got. So basically, any time above one of these, any of these bits above this line, these are all times we can use the boat. These times are not. So we'll find the first 3 maybe, and hopefully it'll be one of those. So if we do arcsine of minus 0.3, 0.6 even, 0.6, we get my principal value, we get theta is minus 36.9. Minus 36.9 is going to be somewhere way over there. Okay, so we need to measure what these other ones are. Now 36.9 has been measured from the 0 location, so where it crosses. So if we add 36.9 onto there, take it from there, add it to there, we should be able to find the other ones. So we got 180 plus 36.9. We're going to have 360 take 36.9 and possibly well, that'd be 540, is it? Yeah, 540 plus 36.9. So if we work out the 3 of those, we get 141.3, 143.1 even, 323.1, and 576. Sorry, that first one is wrong. I did the wrong thing. 180 plus 36.9, 216. So those are my 3 different angles. We need to turn those into a time though, so we're going to divide those by 30. So those at the moment are 30t. I'll divide those by 30. We get 7.23. 10.77. 19.23. Remember, these are hours after midday. Sorry, hours after midnight. So we got this will be 7 something a.m. So no, because we can't leave until 8:30, so it can't be that. The next one will be 10 something. So we do 10 and then 0.77 of 60 minutes. So that's 10:46 a.m. That works. So we're at this time here. A little bit bigger. That's the time we're at. The level is about to rise. So, and we've unloaded the cargo. So yeah, 10:46. As a lot of you guys have said, that's the correct answer. Kezi, it should round to 10.46, though not 10.47, and you would lose a mark for that. They're quite picky with those. All right, next question. Cool. Yes, this one. Cool. All right, so this is all to do with, well, we've got asymptotes, we've got gradients, we've got some calculus. All right, give it a go. This is, how many marks is this one? 10 marks for this, so 10 minutes. All right, give it a go. Cool. All right, how do you guys go on this one? I didn't see any comments for answers, so maybe a bit more difficult. Right, so first up is some implicit differentiation. So yeah, we differentiate each bit of this equation. So x squared differentiates to 2x. 2xy, well, we need to use a product rule on that one. So we're going to get the 2x differentiates to give you minus 2. The y stays the same. Then differentiate the y, we get minus 2x dy dx. 3y squared goes to 6y dy dx. And 50 goes to 0. So there's a differential. We just need to rearrange this to get dy dx on its own. So I'm going to factorize. So 2x, take 2y, plus dy dx minus 2x plus 6y equals 0. Rearrange to get dy dx is 2y, take 2x over minus 2x plus 6y, divide it all by 2, y minus x over minus y plus 6. Y. Free y. Free, what am I talking about? Free y. And that should be an x. Can't do anything today. That's an x. Damn it. Minus x plus 3y. Cool. There you go. So that's part A. Right, part B, find the exact coordinates of point P. Okay, well, point P is this one here. We know it's at an asymptote. At an asymptote, the gradient is infinite. So if we want to make the gradient of this infinite, we can make the denominator equals 0, because dividing by 0 gives you infinity. So we're going to say 3y take x equals 0. So therefore, x equals 3y. Then we need to solve that, so we're going to sub that back into the original equation to find x and y. So everywhere it says x, I'm going to write 3y. So you get 3y squared minus 2 3y times y plus 3y squared equals 50. Expand all of that. So we get 9y squared minus 6y squared plus 3y squared is 50. So 9 take 6 is 3 plus 3, so we get 6y squared equals 50. So y is square root 50 over 6, which does simplify. I think that gives you 5 root 3 over 3. And we know x equaled 3y from earlier. So if we want to find x, we just times that by 3. So x equals 5 root 3. And they should both be plus or minus. Obviously here though, we've got negative x coordinate and negative y. So we get minus 5 root 3 minus 5 root 3 over 3 as our set of coordinates. Okay, last bit, 1 mark. Explain briefly how the coordinates of the point that's furthest north of the origin, so that's this point here, explain how you find them. Well, there's a maximum point, so we're going to set dy by dx equal to 0 and solve. And to do that, we're probably going to need to sub back into first equation. Like we just did basically, but we're using the numerator as 0 instead of the denominator. So sub those two together, solve, and you would find that point. Cool, we're 10 minutes left. Let's try and get through one more of these, or at least get you guys started on it. Yes, it's an 8-mark question. We're not going to go through this today, but I will start the timer and give you guys 10 minutes to start it today. And let's write D. Yeah. Thursday. Cool. All right. If you guys have any questions, please ask. Otherwise, I'm gonna go off cam. I'll still be here, so if you need any help with this one, let me know. So it's differentials, and then solving some stuff. So it shouldn't be too bad, this one. But if comment answers, ask me if you need any help. Yeah. Cool. Right. Cheers, guys. So I'm gonna go off cam, but I will speak to you on Thursday. If you do need any help, I'm still here. So do comment if you need help. Cool. Cheers. All right, cheers, guys. I will see you on Thursday. Bye.